All right, welcome back into another week of Whether or Not. Sponsored by Ford, I'm your host, meteorologist Scott Sumner. Got a good and interesting topic today to speak of. And, you know, we don't always think about volcanoes, certainly not here in the East Coast. That's more of overseas in the Pacific and what have you. But today, I have Jessica Ball. She is a volcanologist on my program today. We were kidding off camera. I said, I don't know how to say that word, so I had to write it out. You said like Star Trek, volcanologist. So I think I've said that pretty well. It kind of smoothly comes off the tongue. How are you this afternoon, Jessica?
I'm doing just fine, thank you.
Good, good, good. So let's get into it. How did you get into your profession? What attracted you to volcanoes?
So I was one of those nerdy little kids who always liked to pick up rocks wherever I went. And growing up in the DC area, we of course had the wonderful museums downtown, and my parents were always very obliging in letting me go to the Natural History Museum as much as I wanted. And so that just sort of fed the fascination, and I discovered volcanoes. And that was it. Just went, full tilt into volcanology, and I don't think I've ever looked back.
That's awesome. Yeah, you were telling me off camera too. You're from Alexandria, so right across the Potomac here. Good stuff. Can you explain how volcanoes do what they do? How do they spew their lava? There's definitely some steps here that go throughout the process.
There is indeed. So at the core of everything, magma comes from deep inside the earth where it's very hot. And so you've got this hot rock, and hot things, as you'll know from meteorology, are more buoyant. They like to rise. So that hot rock rises through the earth, and it also has gas in it, sort of like the gas bubbles in a container of soda. And so the heat and the gas are driving this towards the surface of the earth, and it finds a weakness or a crack or a boundary along a tectonic plate, and takes advantage of that and then pops through the earth's crust. And the more gassy it is, the more explosive it can be. If it's sort of less gassy, or the magma or lava is less sticky, then it flows. And so that also contributes to the different kinds of volcanoes that we get.
Yeah, I'm glad you brought that up, because in doing some of the research before you said yes to come on the podcast, found out that there were two different types of volcanoes. I didn't know that. I had no clue. I only thought there was just one type of volcano out there, as I'm sure many people do. Can you explain the two different types and how they come about?
Right. So the two broad types of volcanoes we get are related to the type of magma that erupts. So when you have a volcano that erupts very runny and very fluid magma, or as lava at the surface, you get what we call a shield volcano. And the reason it's called a shield volcano is because it looks like a warrior's shield, or if you watch certain superhero movies, you'll know what the shape is. And that's because the lava can flow a long way before it cools. So volcanoes in Hawaii, for example, are shield volcanoes. And then when you get very sticky lava that doesn't flow as far, it piles up over the vent where it's erupting. And then you get steeper volcanoes that we call either composite volcanoes or stratovolcanoes. And these are volcanoes like Mount St. Helens, Mount Rainier, Mount Adams, the big tall ones that you see out west.
Yeah, you mentioned the Hawaiian Islands. Are they all formed from volcanoes, basically?
Yeah, they pretty much are. So all of the islands that we know as Hawaii today, and then way on back into the Emperor Seamount chain, which is volcanoes that used to be above the water and have eroded and are now below it again.
So why are different types of volcanoes found then in different places?
So a lot of it has to do with tectonics. So the Earth is made up of these different tectonic plates, basically big slabs of the crust of the Earth and part of the mantle. And these plates move around, and they also have boundaries. So a lot of volcanoes occur on the boundaries in between these tectonic plates. So, for example, where you have one plate that dives underneath another plate, you get what we call a subduction zone. And that's an area where you tend to get the big, tall stratovolcanoes like Mount Rainier, Mount St. Helens. You can also get volcanoes that form over hot spots, which are places where the hot mantle and the magma that's rising up from the depths of the earth have punched through the crust. And this is where we get the Hawaiian volcanoes. And the reason that we have this chain of Hawaiian volcanoes is because this, rising magma acts sort of like a blowtorch. And as the plate moves over it, it burns holes in the plate. So the reason you get that chain is not because the hot spot is moving, but because the plate over top of it is moving.
That's pretty fascinating. So I guess you can say, based on that, that maybe the furthest away from the actual uprising of the magna is the oldest. Is that correct?
That's right.
Yeah.
Yeah,
Okay.
yeah. It's also something that we see with Yellowstone, which is a volcano that forms over a hot spot. If you look back into the eruption history, you have this big long chain of older eruptions that come from the same hotspot as now forms the Yellowstone Park that we know today. And they are further and further away as they get older.
So also too, I would say, Jessica, too, that volcanologist and a seismologist, they have with seismologists for the earthquakes, of course. There is an overlap there. Is that correct? And I guess Ring of Fire would be part of that.
Yeah, yeah. So the Ring of Fire is the name that we give to the boundary of one of those tectonic plates. That would be the Pacific Plate. And it's pretty much just a name for areas where there are lots of volcanoes and lots of big earthquakes. And the overlap between volcanoes and earthquakes or seismology is that when you have magma moving through volcanoes, so through their plumbing underground and as it's erupting, you get earthquakes. It's breaking rock as it moves, forcing it to expand, it's boiling fluids in the crust. And so all of that shakes the earth. And the earthquakes are a little bit different than big earthquakes like we get on faults like the San Andreas Fault out here. They're smaller, they're more numerous, but what we can do with them is by figuring out where they are in the crust, how deep, where they're traveling, we can use them to track magma movement before an eruption happens.
So how is the aspect of forecasting then within your field? Is it kind of like earthquake forecasting in the sense that you'll never really be able to predict when the exact timing of one will occur, yet you get a general scope based on maybe past history? Is that correct?
Right. Yeah. It's a little bit like if you are in weather forecasting and you are trying to forecast a tornado touching down, for example. You know when the conditions are right for a tornado, and you can even track in the radar what's happening with the clouds that form it. And volcanoes are very similar. You get used to the precursors. You see the precursors and you say, okay, in the past, this has been what happens right before an eruption at this volcano. And so you're prepared, but you can never put an exact time on it.
Yeah, and that's the tricky part, and that's the challenge to both of our fields, to be quite honest with you. Now you talked a little bit about lava. Everybody knows lava. What are some of the other dangers that volcanoes possess?
So, some of the other ones, one that's particularly of interest to meteorologists is volcanic ash. So, when you get explosive eruptions from a volcano, that is basically pulverizing the lava that's coming out of the vent. And what you get is something that's very similar to very fine sand. It's heavy. It has all of these interesting properties where it can form its own electrical charges. And so you can even have volcanic lightning come out of those eruption clouds. And it can travel really long distances. And so that becomes a hazard to things like air traffic because obviously you don't want to get sand sucked into your airplane's engines.
Absolutely, and that kind of brings me to another question, because I read somewhere that the ash weighs 10 to 20 times that of snow, and at first I was like, how could that be? But now you described it as sand, and sand is quite heavy there. So that's more truth than it's certainly not a myth, that's for sure.
Oh, yeah.
Yeah, that is true. I wanted to bring you on and talk about this topic because I understand there have been volcanoes erupting in Mexico, etc., around the globe. So that brings me to the question. You're from Alexandria. Where might the closest, volcano be in, say, the Mid-Atlantic region?
Oh, to the Mid-Atlantic, I think geographically the closest you're going to get to a volcano is maybe something in the Caribbean or in Mexico. The east coast of the United States is a very old sort of geologically area, and the most recent volcanic eruptions were hundreds of millions of years ago, and so there are no active volcanoes on the east coast. Um, there are volcanoes sort of out in the middle of the ocean, places like Iceland, or if you go around closer to Europe, the Canary Islands, places like that. The Caribbean has a lot of volcanoes, but because of our weather patterns on the East Coast, you're really not going to see much impact from those. What's more likely is that something out west erupts, like another Mount St. Helens or one of the other Cascade volcanoes, and the ash from those volcanoes travels east. But there's really not going to be any direct impacts from an eruption on the East Coast.
Well, a lot of people are happy to hear you say that, for sure. That's some good stuff. All right, last question for you, Jessica, and this may be the toughest I'm throwing out at you. What's your greatest accomplishment in your field? Do you have one? Can you pick one out?
Oh, one of my sort of proudest, I guess, accomplishments over time has been coming to work for the U.S. Geological Survey. Because we're a public agency, we're a government agency, we get to apply our research to actively help people. And so that's what really makes me happy about my job, is that I can take the work that I'm doing and the research that I do about volcanoes and actually use it to help keep people safe, help keep them informed, and just help them appreciate the really dynamic Earth systems that we live with.
Yeah, it's a jigsaw puzzle, as I like to call it, below where we can't see, really, with all those tectonic plates that are underneath our feet. Well, thank you. I appreciate your time here, and let the people know, if you wouldn't mind, plug where they can find maybe some of your research or some of the work that you're doing, Jessica.
Yeah, so you can check out the USGS Volcanoes websites, or we're also on social media on Twitter, Facebook, and Instagram. And we post new content every day, pretty much. And you can find out all about the different volcanoes that are active and erupting in the United States.
All right, good stuff. Be safe, of course, and again, thank you for spending a few minutes of your time with me today. That's Jessica Ball, who works for the government there, a volcanologist. I said it right again. All right. Well, that should wrap it up for this week's podcast, sponsored by Ford. As always, God bless, be well, stay safe, and we'll talk again next week.